All right, so 3-3 factoring polynomials. The first three are really going to throw some kids off. You just need to decide what pattern you're doing here. Like here I see a cube and a minus and a cube. And it's legit this pattern right here. That's what it is. So you have something cubed. A is the 12 on this one. You have something cubed. B is 8. And you just follow the pattern. Like that's really all you do. The first set of parentheses is simply 12 plus 8. On the next set of parentheses, you take A and you square it. That'd be 12 squared. And you'll notice I'm doing the minus one. It's a plus and a plus. This says plus A times B. So plus 8 times 12. And there's another plus B squared. And I got those backwards, but it doesn't matter because it's multiplication. Plus 8 squared. That's really all there is to them. You just follow the pattern. But does everybody get that? No. All right. Let's look at number 5. Now, 5 may not appear to be a special pattern, but it is if you pull out the negative 5 first, as I'm suggesting. So we're going to pull out the negative 5. We're going to think about what that leaves us to have left over. Obviously, if you pull a negative 5 out of z cubed, negative 5z cubed, sorry, you're going to have a z cubed. How many times does 5 enter 320? Seems like 5 enters 120 times. You multiply that by 3, that'd be 60 times. And 5 enters 24, 64. And you pulled the negativity out of a positive, so now it's negative. That little guy right there is a special pattern. A is the cubic root of z cubed, which is z. B is the cubic root of 64, and if you don't know how to do, if you don't know your cubic roots, on your TI-84, you type 64 to the 1/3 power. And you get 4, and you remember that for the rest of your life. It's 4. And then I'm just going to follow the pattern. So this is something cubed minus something cubed. I'm going to be using the pattern a cubed minus b cubed. She factors as a squared. Remember SOAP? Same. Oops, got ahead of myself. I'm thinking about the third set. It's a minus b. Remember SOAP? Same. A squared. O for opposite, so plus a times b. And then we have AP, always positive. If you don't know what I'm talking about, you weren't paying attention yesterday. Signs are the same. Signs are opposite. The last one is always positive. So there's the form I'm plugging into. And you can also see that on the upper right-hand corner of your piece of paper. So anyways, I have figured out that z, a is z, and I'm going to be taking away b, which is 4. I'm looking at this right here. I'm going to have to square the z. I'm going to have to multiply z and 4 together. That's 4z. And then I'm going to have to square b. 4 squared is 16. Now, the piece of paper says only real solutions, right? This one is always 2 imaginary answers. That's all it is. It's always imaginary. So the only real answer here is that using zero product property, that z minus 4 is 0, which means z is 4. Now, I'm nice to y'all. A couple years ago, we had to do both of them. So I don't want to hear any complaining because you're doing half the work. You need to get that. You're literally doing half the work. All right. 9's probably intimidating the kids. 9 is a trinomial. And every trinomial that exists is going to at least start off by factoring with a double set of parentheses. Sometimes if they contain a number that's a factor of L3, you pull that first, but this one's not. So we have an S, and you can change it to an X if you want. It's fine. But to make a 3s to the 4th, you need a 3s to the squared, sorry, to the second, and another s to the second. Now I'm going to focus on the 24 at the end. Factors of 24 would be something like 6 and 4, 8 and 3. I feel like it's 8 and 3. Let's see if I'm right. The inside here would make 8s squared. The outside would make 9s squared. And if you look at your goal is to have a negative s squared. So I need that one to be negative and that one to be positive. plus minus. Now, you get to use your zero product property, because remember this thing was equal to a 0. So we're going to do the zero product property. 3s squared plus 8 is a 0, or, this one actually could factor if you know how to factor, s squared minus 3 is a 0. I promise you it does factor. It factors s plus root 3 and s minus root 3. Well, let's look at this one here. We're going to have 3s squared equals negative 8. We're going to divide out the 3. We're going to have s squared equals negative 8 over 3. That's going to give me that s is the plus or minus the imaginary root of 8 over the imaginary root of 3, and this is not real. So I'm not actually interested in that answer because all I wanted was the real ones. By the way, you know, I wish that stuff was still in your standards. To clean this up, we would take the numerator and denominator and multiply them both by root of 3, and we would have plus or minus the imaginary root of 24 over 3. 24 is 6 times 4. This would become plus or minus the imaginary 2i root 6 over 3. But that's not in your standards because it was deemed too hard for you. And we wonder why academic excellence peaked in 2013, because we took away all the hard stuff. All right, the easiest way to do this one is probably to shift your 3 to the right-hand side. Counteract a square with a square root. Don't forget your plus or minus symbol. And that would be your s values. Plus or minus root 3. It is a real number. It does exist. I swear it does. And moving forward with our lives, let's look at number 11. 11 looks like a fun one. I should probably do 12, but nah. How many of those factoring by groupings do I have on here? Because I don't want to do all your factoring by grouping problems. I don't have enough, so no, I'm not going to do 12. If you want 12, you need to ask for 12. 12 is a factoring by grouping problem. 11 looks kind of interesting, although so does 10. Let's do 10. So I see the numbers 15, 72, and 108. And my gut says they're all divisible by 3. And I trust my gut. It's usually right. I also notice they all contain an x. So I'm going to pull that x too. I'm going to pull out a 3x. That's what I'm going to do first. If I pull a 3x from 15x to the 5th, I'm going to have 5x to the 4th. If I pull a 3 from 72, that's going to be a negative, what, 24? And I still have x squared left because I pulled an x from x cubed. And how many times is 3 under 108? I believe 36 times. And so we have minus 36. And I pulled the x. So you got that thing, which still to some is quite scary. I get that. But you have a trinomial. See that? 3 pieces. Trinomial. And all trinomials will factor with a double set of parentheses, if they do in fact factor. Hopefully this one does. We'll find out. So to make a 5x to the 4th, you're going to need a 5x squared and another x squared. My gut is saying that 36 is going to take a 6 and a 6. I feel like that's right, because the outside would make 30x to the 2nd, and the inside would make 6x to the 2nd. I want a negative 24. 6 minus 30 is negative 24. All right, now we're going to hit this thing with what's called the zero product property, which you should have heard unless you literally live under a rock. There are 3 things that, according to the ZPP, equal 0. 3x is equal to 0, or 5x squared plus 6 is equal to 0, or x squared minus 6 is equal to 0. Those are your 3 things. This one's like super easy, but kids miss it. X is nothing. If 3 times x is nothing, x is always nothing. This one, it'd be cool if you guys could realize what's going to happen, because it would save us all a lot of trouble. You're going to subtract 6 from both sides. You're going to divide by 5. And if you haven't stopped by now, you should have right then, because this is not real. And I did not ask for the non-real solutions. I asked for the real ones. Shift right. X squared is going to be 6. The opposite of squaring is square rooting. Do not forget your plus or minus symbol or the baby panda dies. Remember that meme? Don't kill the baby panda. What did it ever do to you? Just do your math right. Ooh, I got 3 minutes. I'm not going to spend as much time making these videos as I used to. I'm running out of time. I get up here at 5-ish anyways, so you're just not going to get as much as you used to. But you're going to get a little bit. Hopefully it's enough for you. 14 is kind of interesting because the reason 14 is here is because you're going to start working with exponents soon. And you're not going to like it, but I'll save that for class if you can't figure it out. 13, if you see 4 terms, it's probably what we call factor by grouping. And you do not have to solve these. It even says there is no equal sign. Do not solve because there's no equal sign. But this is going to be factor by grouping. If you see 4 things, it's factor by grouping. If it factors, this one should. I made it up a couple years ago. So I'm going to look at the first 2 terms. And what I see they have in common is they both possess c squared. So I'm going to pull that c squared. If I pull a c squared from 7ac squared plus bc squared, I'm going to have 7a plus b left over. Now, my goal is to create this same exact factor right here. Now, can I do that? I believe I can, because both of these possess a d squared, and if I pull a negative from a negative, it's going to become a positive. I kind of have a rule that you should always pull negativity out. So we're going to pull a negative d squared out. And think about what you know about the distributive property. If I put those 2 together right there, I'm going to have 7ad squared, which is what I have. If I put the last 2 together, I'm going to have bd squared, which is what I have right there. So it makes sense. Now, there's actually only 2 terms here. This is hard for kids to swallow, but there's only 2 terms now. Weird, huh? That's because of the multiplication operation. If you multiply 2 things together, you've only got 1 thing. Both of these things are in possession of 7a plus b, and the other factor is the stuff left over, c squared minus d squared. Now, your instruction set said factor completely. This one's not done. That is an a squared minus a b squared pattern, although with the letters c and d. So the a squared minus b squared pattern would factor with a negative and a plus. Just do the lineup process. This is a, this is d. A, d. Done. It's not that bad. Will you remember how to do it come quiz test day? Not a clue. Gut says no. Prove me wrong. Let's see here. Bell just rang, but I'll go ahead and give you 15. Play along. It even says, by all means, use your graphing calculator. Oh, I can't do that because I don't have my calculator app up. I don't know if I'll be able to import it either. Maybe I will. We'll find out. If not, this one actually works out by hand. So a rectangular prism, it says you might draw it. It wouldn't kill you to draw a prism. It looks something like this. You would dash the stuff on the inside because it's not really seen. Has a volume of 40 cubic units. Its length is 2x. Its width is x minus 1. I had to put that in the wrong spot there. It doesn't really matter. Its length is 2x. Its width is x minus 1. And its height is x minus 4. And it has a volume of 40. Now, I even gave you the formula here. You're going to put a 40 there for v. And these 3 things are all interchangeable. You can put them wherever you want. Doesn't really matter because you're multiplying stuff together. And you're asked to find the value of x. And it says, feel free to use your TI-84. So you have a y1, y2 operation. You don't need to put that big ugly thing right here in standard form. It's not going to do you much good, so I wouldn't do it. Let's see if I can actually pull up my TI-84. Ooh, I can. I didn't think I'd be able to. Good news. All right, so on y equals, I'm putting the 40 in y1. I'm going to put the rest of this junk in y2. You do need to learn how to play with your window. So it says, tell me how you use your calculator. Obviously, you put 40 in y1. You put the other one in y2. I should have asked for the domain of this thing, too. Too late. Zoom 6er. And you're going to have to play with a window. You are, because you put a 40 in y1. That's a horizontal line where y is 40. And if you ain't figured it out by now, this thing only looks up 10 units. So you're going to go to Window. I'm going to set my y max to be 50. Play along again, boys and girls. Hit the old graph key. That's something I did here. I set my y max equal to 50. Now what I'm going to do here is I'm going to do second trace intersect, because solutions happen where two things cross paths. So second trace, 5 for intersect. Get your little cursor close, and then you're going to press that enter key 3 times. Enter, enter, enter. And there you go. The solution was 5. X equals 5. Now, I need to read the full question. Am I just finding X, or am I finding anything else? Oh, I just wanted X. So yeah, we're good. We're good. Sorry that little thing got in the way there. I don't know why it does that. It's annoying as can be. To actually get it back, I have to drag it over here. And I can, there you go. And that's where I'm done. Hope you enjoyed the video.